Assalamualaikum and hi there. I'm Shikin Aziz. Following to video on water for food industry. In this video, I will further explain the water characteristics that will affect the cleaning and disinfection, or also best known as sanitation process. Sanitizing solutions generally will consist approximately 95 to 99% of water, as water main functions are to carry the detergent or sanitizer substances to the surface, and then the water will create a force to remove the soil or the deposit or contaminations, and then it will carry the salts or contamination away from the surface. The impurities in water can easily affect the effectiveness of the sanitizing solutions. These are the characteristics. I illustrate most of the characteristics that will influence the sanitation process. You can see there's a lot, right? From these characteristics, water hardness is the greatest influence that will direct affect the cleaning and sanitizing efficiency. So I will focus my explanation in this video on water hardness only. Water hardness is defined as the amount of dissolved calcium and magnesium in the water. Hard water is high in dissolved minerals and mostly calcium and magnesium. Do you know how does water become hard? No worry if you don't know. I have found this interesting animations video which explain the formation of hard and soft water. This video is produced by few school YouTube channel, and I hope you will find the time to watch this hard and soft water video. Okay, so now let's proceed. Heating is a common process in food industry. Now let's look what happens if hard water is heated or evaporated. Calcium and magnesium and bicarbonate ions in hard water will precipitate and form this is bicarbonate ions. Okay, this is bicarbonate ion. When calcium and bicarbonate ions and magnesium and bicarbonate ions combine, it will precipitate and form calcium carbonate, calcium carbonate and magnesium hydroxide. Alright, for reaction with combination with calcium and bicarbonate ions, it will also form water molecule and carbon dioxide. While for magnesium combined with bicarbonate ion, it will form magnesium hydroxide and carbon dioxide. Okay, so this one G stand for gas, S stand for solid. S, so we can see here the formation will create some solids, some solids particles, and AQ here stand for aqueous, which shows that this can be this molecule is dissolved in water. So calcium and carbonate magnesium hydroxide is less soluble in water. Alright, it's less soluble in water, and it is known as scale and lime scale, or also called as lime scale. Alright, scale normally appears around the heating elements. This photo shows the heating element, electrical heating elements in the hot water system. And normally in the hot water system as well, like boiler, heat exchanger also can easily find. We can easily we can easily get scale formation if let's say the water is not treated properly before use. Alright. Soaps are commonly used cleansing agents and are capable of reacting with water to remove dirt. And the soap molecule is commonly represented as RCOONA, which also called as sodium salt of carboxylic acid, or commonly known as sodium stearate. And sodium stearate is soluble, is soluble in water. In solutions, this molecule, alright, the sodium stearate, ionize to form RCOO negative molecule and sodium ions. Right. each soap molecules has polar head group, which is carboxylate ion. This is carboxylate ion. Alright, this we call carboxylate ion or COO negative group. And then this long non-polar hydrocarbon tail is actually R group from long chain fatty acid. The polar head will attract the polar water and is known as hydrophilic end, while the non-polar tail here will attract the water insoluble oily or greasy soils. Alright, although soap is a good cleaning agent, its cleaning capacity is reduced when used in hot water. Alright, let me show the illustration. Okay, so when you use soaps in hot water, this what will happen. Alright, sodium, potassium, ammonia soaps actually are soluble in water. However, in hot water, calcium, magnesium ions will react with soap. Okay, will react with soap molecules to form calcium magnesium salts. Alright, this is calcium salts, magnesium salts, which actually this salts molecule results of the combination of soaps molecule and the calcium and magnesium ion. Okay, is also known as soap scum. Soap scum. Alright, hence water hardness is actually will affect alkaline cleaning, as the sodium soap will not emulsify the soil, but it reacts with the hardness that present in the water. Hence fouling deposits, alright, scale problem will increase. Okay, and this is the chemical reaction that involved when the water soaps been used in hot water. Alright, when the soap been used in hot water. Okay, so we can see here this molecule around here. Okay, combination with soap molecules with the hardness. Alright, is a solid, it's a solid substance, and these scales, alright, as I said, it will form in the equipment surface. Alright, this scale actually can also provide a secure place for microorganisms to attach and grow. Alright, and it will promote more growth, more microorganisms to grow within the structure of the scale. And scale will also damage the equipment, increase corrosion, and plug the pipe in boiler and heat exchangers. Furthermore, scale will make cleaning and sanitize practice becoming more difficult. Now, you know that when calcium and magnesium ions combine with bicarbonate ions, it will form insoluble mineral deposits, and is also known as these bicarbonate ions. And this combination of hardness, calcium and magnesium with the bicarbonate ion, will form insoluble minerals. And this insoluble minerals, or this reaction, is also known as temporary hardness, as it is easily removed by simple heating and then followed by filtering. Alright. Apart from this, other than bicarbonate ions that presents in the water, calcium and magnesium can also combine with chloride. Sometimes inside the water there is a chloride, sulfate, and nitrate, but this is known as permanent hardness, where water softener is required to remove the hardness. However, hardness value are usually quoted as calcium carbonate, because calcium carbonate is the most common cause of scaling. The standard classification are given in this table, and if let's say hard water is used, generally what the industry will do in order to reduce the effect of hardness, they will use formulated alkaline cleaner. Alright, where this formulated alkaline cleaner has a agent of where it can reduce the hardness, such as calcium chelate or sequestering compounds. And this will reduce the effect of water hardness. Or the raw water before being used in the plant is treated with softener by applying resin, or another way is by applying acid final rinse. Alright, with acid final rinse during cleaning procedure to keep the equipment clean. Alright, as the acid can dissolve minerals. Since using hard water will generate more problems, alright. And how does soft water? Do you think it's good for cleaning? Right. So unfortunately, soft water also has its own issue when come to cleaning application, due to cleaning with soft water will generate so much foam, and detergent will be difficult to rinse out, and it actually leaving some residues. And soft water can be corrosive, to equipment and even to aluminium cans. And finally, it can cause corrosion too by moving the Langelier index. Alright, so common application of water softener in industry is they will have a bypass. They will have a bypass to mix hard water with soft water to obtain reasonable water hardness, which is between 30 to 50 ppm. Which is the best water hardness actually that need to be aimed for industry applications, alright, in order to reduce the effect of hardness, as I explained just now. I think that's it for now. For other explanation on other water characteristics, it's better I explain it in other video. Alright, so thank you for watching, and see you again. Bye.